Hi, and welcome to Week 1, Mini Lecture 1 for the Quantum Universe for Educators. In this brief video, I'm going to motivate why we should care about quantum mechanics and talk a little bit about the aims for this class. I'm going to start off with the question, what has quantum physics ever done for us? And our starting point will be this device, the transistor, invented in 1947 by Bardeen, Brattain and Shockley. It is one of the most fundamental components in electric circuits. It controls electric current and it replaced vacuum tubes. On your left are some older fashioned versions of the transistor. On your right is a modern integrated circuit. The most modern integrated circuits can contain millions, even up to billions of transistors in them. Now, the transistor is a quantum device. It could not exist if quantum physics was not an accurate theory of nature. Therefore, your mobile phones and laptops would not work without quantum physics. We would still be using computers the size of rooms, like we were in the 40s and 50s. So without quantum physics, anything that contains modern microcircuitry and computers would not exist. That includes mobile phones and laptops, as well as even kitchen appliances such as microwaves. There are computers in your car, in modern planes. There are many other devices that only work because of quantum physics. LEDs, for example, are quantum devices, so holiday lights that use LEDs can only exist because of quantum physics. Hard drive storage uses principles of quantum physics. Lasers are quantum devices. Medical imaging, such as MRIs, CAT scans, electron microscopy, these can only exist if quantum physics is correct. Without quantum physics, the vast majority of modern technology cannot exist. In fact, you could ask, without quantum physics, what would work? The modern world has been shaped and made possible by quantum physics. Now, every time you turn on your laptop or you call someone on your mobile, the very fact that it works confirms that quantum physics is an accurate theory of nature. But scientists are never satisfied and want to test the theories of nature to as great a precision as possible. One way they have done this with quantum physics is to measure what is known as the anomalous magnetic moment of the electron. The electron is a fundamental particle which spins, and because it has a charge, it also has a magnetic field associated with it, and therefore a magnetic moment. By measuring the magnetic moment, you can figure out how strong the electromagnetic force is compared with the other fundamental forces of nature. And that strength is expressed by the fine structure constant, which is denoted alpha. We will encounter the fine structure constant later on in this class. At the moment, it is sufficient to say that the theory of quantum physics predicts what the value of alpha should be. It should be 137.035999709. We've been able to measure the anomalous magnetic moment and therefore the fine structure constant to only one significant figure less than theory predicts, and it agrees perfectly with what theory predicts. This makes quantum physics the most precisely tested scientific theory of all time. So what is quantum theory? Well, it's likely that you've heard certain terms associated with quantum theory before. Quantum theory may rival astronomy and astrophysics for the scientific theory that has made most of an impact in the public's imagination. Terms like quantum theory, quantum mechanics, quantum field theory, quantum leap, quantum entanglement, these are all terms that many of us have heard of, even if we don't fully understand what they mean. Concepts such as Heisenberg's uncertainty principle, Schrödinger's cat, and wave-particle duality, many people have heard of these things, but few people have a good understanding of what they actually mean. And it is important to understand what quantum theory actually means. I've put up here 6 quotes that involve quantum physics in some way. Some of these are accurate statements about aspects of the theory, some are expressions of how mysterious the theory is, and some are flat out incorrect statements. We're going to need to be able to figure out what statements are accurate and what statements are inaccurate when it comes to quantum physics. Take a moment to read through these quotes and see if you can guess which ones are accurate and which ones are not. Okay, this first quote is from respected science journalist John Gribbin in his book In Search of Schrödinger's Cat, and I think it accurately expresses one of the main problems that people face when trying to understand quantum physics. The predictions that quantum physics makes for the behavior of microscopic particles means that it is, if not impossible, extremely difficult to intuitively picture the behavior of atoms and subatomic particles accurately. They simply do not behave anything like objects behave at our level. That is something that we will be discussing at length later on in the class. The second quote here is from self-help book and latterly self-help empire, The Secret. And this expresses a very common misconception that quantum physics predicts that your mind, that your consciousness can alter reality. Your mind and your consciousness cannot alter reality. Quantum physics does not say that. It is a very widespread misconception, however, and we'll try and understand why this misconception comes about later on in the class. This third quote is from another self-help guru, Deepak Chopra. I'm not exactly sure what he's trying to say in this quote, but both this quote and the quote from The Secret illustrate something very important. When people are trying to sell a certain product, such as in this case, a self-help program, quantum physics is one of those areas of science that they reach for in order to try and sell it. They're preying on public misconception of what quantum physics means in order to get you to part with your hard-earned cash. And this is one example of why a good understanding of quantum physics is important not just for research scientists, but for the public. This fourth quote is from Albert Einstein, and the fifth quote is from Werner Heisenberg and is a statement of his own uncertainty principle. The sixth quote is a little more light-hearted. This is from renowned science fiction and fantasy author Terry Pratchett. So, with that said, these are the basic aims of this class. We're going to try and give an account of how quantum physics came about by reading the original papers by the founders of quantum physics and seeing what a true scientific revolution actually looks like. We're also going to look at the physics of quantum physics, that is, try and understand the principles of quantum physics and apply them to solve problems and understand modern applications. We're going to make heavy use of the two required textbooks in this portion of the class. And finally, we're going to look at some pedagogy. We're going to see how we can explain these mysterious concepts of quantum physics accurately to students and the public. And we're going to look at how we can tell pseudoscientific expressions of quantum physics from scientific expressions of quantum physics. The required text, How to Teach Physics to Your Dog, is an excellent example of how to creatively communicate the concepts of quantum mechanics to the public. And so it'll be useful not just to understand the principles of quantum physics, but to see how you can convey them to other people. So I look forward to leading you throughout the rest of this course.